This is a video on tangent planes. The question states, find an equation of the tangent plane at the point -4, 3, 2 to the surface represented by the vector-valued function r of uv is equal to uvi plus u plus vj plus the square root of vk. So I will start by finding the values of u and v that give us a point -4, 3, 2. It's easiest to use the third component, this root v, because the other two components both have u's and v's in them. So I can say that 2 is equal to root v, so that v is equal to 4. So now that I know v is 4, I can use the second component, u plus v, is equal to 3, and if v is 4, then u plus 4 is equal to 3. Subtract 4, and I get that u equals -1. So now that I have the values for u and v, let's find out what ru and rv are to get the normal vector. So the partial derivative with respect to u of r is equal to, well, the partial derivative with respect to u of uv is just v. The partial derivative with respect to u of u plus v is 1. And the partial derivative with respect to u of the square root of v is 0. So I get that r sub u is equal to vi plus j. Now I have that u is -1 and v is 4, so I plug in, and I get the partial derivative with respect to u of r at -1, 4 is equal to 4i plus j. So now let's find the partial derivative with respect to v of r. And that's equal to ui plus 1j, or plus j, and the derivative of root v is 1 over 2 root v, so I get plus 1 over 2 root v k. Now let's plug in u equals -1 and v equals 4. Notice that 2 times root 4 is 4. So what I get is -1 times I, or -I, plus j, plus 1 over 4, k. So now that I have r sub u and r sub v, I can find the normal vector by taking the cross product. And I do that. I take the determinant of ijk. I have 4, 1, 0, and -1, 1, 1/4. And I take the determinant, and I got 1/4 I, and then minus 4 times a fourth is 1, so minus 1j, and then plus 4 minus -1 is 5, so plus 5k. So there's my normal vector. Once I have a normal vector and a point, I can find the equation of the plane by taking the dot product of the normal vector with the displacement vector between x, y, z and the point. And I should get 0 because that's what a normal vector does. It's always orthogonal to a vector on the plane. So I can say that 1/4, -1, 5, dotted with, I have x minus -4, or x plus 4, y minus 3, z minus 2 is equal to 0. So now just compute the dot product. So I have a 4th times x plus a 4th times 4. That's a 4th x plus 1. Then we have a -1 times y is minus y. A -1 times -3 is plus 3. We have plus 5 times z. And then 5 times -2 is minus 10. And we set that equal to 0. So now let's just clean this up. I combine like terms. 1 plus 3 is 4, minus 10 is -6. I move the -6 over as a positive 6, and then multiply through by 4 so I can clean out the fractions. And I get that the equation of the tangent plane at this point to this surface is given by x minus 4y plus 20z equals 24. And I'm done with the problem.